By the end of this lesson, students should be able to use the Pythagorean theorem to find a missing side of a right triangle or to determine whether three sides of a triangle form a right triangle. The opening activity includes a worksheet where students will understand why we use a squared plus b squared equals c squared. This will help them to be able to remember it much better. So the worksheet has a right triangle drawn in that is 3 inches, 4 inches, and 5 inches. So students need to understand. And so if they are not familiar with the right triangle, they need to know that the two shorter sides are known as the legs and the longer side is the hypotenuse. So to review, we ask the student, what do you know about triangles? What do you notice about this triangle? And if they need prompting, then you say this is a right triangle because it has a right angle. You can tell it's a right angle because of the small square. This triangle also has special names for its sides: leg, leg, hypotenuse. The hypotenuse is the longest side and also opposite the right angle. Let's name the two legs A and B and the hypotenuse C. Pass out 1-inch square tiles to each student. You may purchase square tiles or you can cut construction paper or index cards as I've done. It's better to use different colors. The students are able to keep track of which side is which better. So then you ask the students to outline the outer part of line A, side A. Ask them how many squares did it take to make that outline. The answer is 3. Now ask them to do it for B. How many tiles does it take to outline side B? The answer is 4. And then do the same for C and they will tell you 5. Now ask them to make a square out of each side. So you can show them. And what I did with my students is I showed them this and I asked them, does that make a square? If they tell me yes, I remind them, what does it mean to be a square? It means that all sides have to be equal. Do they look like they're equal sides? No, they do not. That makes a rectangle. How can we turn it into a square? We need to add another 3 tiles. Now that makes a square. So side A, we started out with 3 tiles. How many tiles did it take to make a square? 9. So 3 squared equals 9. Okay, and then we do the same for B. So have them make a square . And you'll want to walk around and make sure that they are making squares, because sometimes students see this and they think that that looks like a square, but it can't be a square because it has 4 across and 3 down. So they need to make sure that they have an even number on both sides. Then you ask them, how many tiles did it take to square side B? The answer is 16. So 4 squared equals 16. By the way, this lesson followed our square and square root lesson. So students understand that when you square something, it means you're using it as a factor 2 times. So you do the same with side C. And when it's all done, you end up with a 5 by 5 square, or 25. Okay, so now we have A was 3 sides, 3 squared equals 9. B was 4 sides, 4 squared equals 16. C is 5 sides, 5 squared equals, they'll tell you 25. Now ask them to add the number of tiles for the square of A, side A, so that's 9. Add that to the tiles for B. What do they get? 25. And how many tiles were there in C? Also 25. What do we notice about the sum of the tiles of side A and B squared and the sum and the number of tiles for C squared? They're the same. What equation can we come up with to explain our thinking? Well, 25 equals 25, right? 9 is A squared, 16 is B squared, and 25 is C squared. The sum of the square of A and B is equal to the square of C. That is the Pythagorean theorem.